Hello! ThinkBooster is a unified framework for test and compute scaling of LLM reasoning. It has three main components. First, a strategy library implementing 9 scaling strategies: beam search, best of n, self-consistency, deep conf, and more, scored by process reward models, uncertainty estimators, and LLM as a critic. Second, an OpenAI compatible REST API that turns any LLM into a reasoning enhanced endpoint. Just change the URL path to switch strategy and scorer. No code changes needed. And third, an evaluation pipeline for math, science, and coding benchmarks with Git configs for reproducible experiments. To understand how the strategies actually work, we built an interactive visual debugger. The debugger lets you compare multiple strategies side by side on the same problem, inspect step-by-step reasoning traces, and see how scorers evaluate each decision. Let's select a cached example. Finding the smallest positive integer, satisfying 3 modular congruences, a Chinese reminder theorem problem. Let's compare all of these 5 strategies one by one and start with baseline. For baseline, we can see just one-shot generation. For self-consistency, we can see 8 independent traces of reasoning. Then for an online best of n, we can see reasoning tree. For beam search, we can see more advanced version of reasoning tree. And for offline best of n, we can see 8 independent traces, where each of these intermediate steps has its own score, assigned by process reward model PRM. Notice how they make different quality compute trade-offs. Baseline solves it in one shot, self-consistency generates 8 independent paths and takes a majority voter, while beam search uses thousands of tokens for multi-path exploration guided by the process reward model. Let's inspect trace for beam search strategy. The reasoning timeline shows how the model explores step by step. At each step, the PRM scorer, the process reward model, assigns a score, and the search expands the most promising candidates while proving low-scoring ones. We can inspect individual reasoning steps, see candidate scores, and trace exactly where the model commits to its approach. The trajectory tree gives a global view of the entire search. Nodes are reasoning steps, and the orange path highlights the final selected trajectory. ThinkBooster brings together a strategy library, an OpenAI compatible API gateway, a benchmark evaluation pipeline, and an interactive visual debugger, all in one framework. It's designed for researchers who want to understand, compare, and iterate on inference time scaling strategies. The code is open source and available on GitHub.